It's stored very good. It's stored in the posterior, okay? This is where it's stored. So this one controls this. What it does, it releases in your the number one question for your thyroid metabolism, the question in point form or flow chart. So you're gonna start with low T3, T4, it says there, right? So if your hormone is low, what's going to happen? So this is how you should have answered that number one. The hypothalamus will, this is just the arrow point flow chart. This is what will happen. The hypothalamus will release the thyroid releasing, remember, it releases either releasing hormones or inhibiting hormones. Then it will tell the pituitary to secrete the thyroid stimulating hormone. Then this goes to the thyroid gland to stimulate the thyroid gland. So, what will the thyroid gland do? Make more of this, see, negative feedback. The purpose of that number one homework was so you understand the negative feedback, okay?
So this is
So,
negative feedback.
yes, right? This is low, then this will start releasing and secreting high. So you see negative feedback mechanism. So this one, by the way, so remember this one secretes hormones that targets this one, and this is another endocrine gland. So what do you call these hormones? Remember, trophic hormones. Remember the trophic hormones? These are hormones secreted from one endocrine gland to another endocrine gland. Remember this one because it will help you for your test, your lecture test in the past.
TRH and TSH?
This is releasing hormone.
And
This
Not
one
secrete,
stimulating hormone, right?
The E14.
B1.
Oh.
This is the pituitary gland.
That goes with the thyroid.
This is the pituitary gland, okay?
So it goes with your pituitary.
Yes, so in other words, the thyroid stimulates the hypothalamus stimulates the pituitary, and the pituitary stimulates thyroid. So this is another example of trophic hormone, right?
Okay, so how about the other ones now? The thyroid gland, the parathyroid.
So now they have.
Do they come from the hypothalamus or do they?
No.
Where do they
the
come from?
thyroid. What do you mean? Where do
The
they come from?
thyroid. I mean, do they make their own hormones?
Yes.
Okay.
Remember so the
Right.
parathyroid makes what? Parathyroid hormone, right?
PTH, yeah.
Yes.
Control
And then
calcium.
your thyroid, see, it's making its own hormone, T3, T4, it's making its own hormone, right?
It's just, the pituitary is basically just telling the thyroid to make it.
Yes.
Yeah.
The pituitary also secretes what? Growth hormone. Now this one, the target organ is direct, your
So the
bones,
pituitary
your-
gland tells the thyroid gland to make the T?
Yes. Yeah.
Okay.
T3,
Yeah.
T4.
Yeah. It's telling it to make it. So it's all communication. Remember, endocrine system is communication. That's how they talk to each other.
And does the pituitary gland also tell the adrenal glands to make hormones, or is that separate?
Look at what does it say? So where's your pituitary? Let's look at our book. Anyway, the answer is no, okay? So the adrenal gland has its own.
The adrenal gland has its
So
own.
it all, if you, I think I have it in my PowerPoint, right? This.
Yeah, they have like aldosterone, cortisol. Like they have like the
Aldosterone,
aldosterone,
yes.
cortisol.
Oh, I didn't bring the blood.
Yes.
I forgot my blood PowerPoints.
Okay, one more time. So how these hormones work? It just hormones, the endocrine system monitor everything. if there's any decrease in let's say, it controls everything, okay? And the way they control is by secreting hormones. So each and every endocrine gland responds to a certain level of something. Like my pancreas, that's an endocrine gland. It responds to the level of sugar. It won't respond to the level of thyroid hormones. This is the one that responds to that one, right? How about the level of your calcium? It's the parathyroid hormones. The parathyroid gland that responds to that one, right? So they have their own area of specialty. Does it make sense? Okay? But that's how our body is able to maintain homeostasis. It's just an automatic thing. Okay? Do you think you got it, everybody? What do you think? Okay? So, use that the flow chart like this, okay? Your flow chart, the first question. And your I remember in the past, my lecture test had something like this, so don't forget, okay? So, I remember in my lecture test, what I had was T3, T4, and then TSH, and then TRH. In the past, so I would ask, what is this? What hormone is secreting that one? Hypothalamus, right? What hormone is secreting this one? Anterior pituitary.
You mean what organ is secreting that?
Sorry, that's
Like-
sorry. And then what endocrine gland is secreting this? Thyroid gland. I usually interchange. I would either use this one and ask you to give me the hormone, or use this one and ask you to give me the gland. But I have been faithful in using this flow chart because you have it in your worksheet. So hopefully you will not forget. It comes out, Jordina, okay?
And the other one is the pituitary. The hypothalamus, the pituitary.
This is hypothalamus, this is pituitary,
Pituitary.
and then thyroid gland. See? It's like, what do you feel like, the general talking to the
Commander.
commander,
talking
and
to
then
the
the commander.
sergeant.
Yes, all of it. See? Chain of command.
And the
Okay.
thyroid is
It's-
the peon at the
It
end.
is. It's very, very orderly, the way they communicate. But you know, these hormones that they secrete, remember we discussed, it's either fat-based or protein-based. That's why we need the fat and the protein in our diet. They're used to make all these different types of chemicals. Okay? So what's helping you with your heart rate and all the stuff? That's your thyroid hormone. What's helping you grow? Growth hormone. What's helping in calcium homeostasis? Parathyroid and calcitonin. By 242 is a bit different. It's more practical, I think. I like it more. So today we're going to start with blood. So we're going to start with the next body system, which is your cardiovascular system.
Are you going to go over steroids?
Steroid.
Because there's a whole bunch of questions in the worksheets that aren't in the book.
Yes, you're supposed to research.
Yeah, well, when you type it into
go to
Google
the
and Google goes, what?
What about the steroids?
Just the steroid alternatives is what I was having a problem finding out.
So what are the two reasons for the use of steroid alternatives? What do you think? What are the two
Well,
reasons?
I don't know what steroid alternatives are.
So,
That's what I'm stuck
like-
on.
Bulking up or
Bulking
something?
up and
Yes. So you just practical reasons. Why do you think people use steroid alternatives?
Is that like synthetic steroids?
Yes,
Is
the
that what you're-
synthetic steroid.
Oh, okay. I'm looking for actual, because you say identify two hormones that are considered steroid alternatives. And I'm like, they wouldn't be steroid alternatives if they were actual hormones, would they?
No, there are several hormones because now you know this the question is about
I'm overthinking
how
it, aren't I?
yes how people because no steroids are banned.
Yeah.
So what is it that they use that mimic steroid effect like growth hormone? They use that one. Yes.
I was just wondering, like, couldn't people use steroids to like defeat diseases too, though? So could you put that down? Because those are like used in
Yeah, they can
medication.
use that one too. Yes.
Okay, I was just
Yes.
wondering.
But uh,
Like-
most often they use it for bulking up, right?
What is it called?
Bulking up. Is it?
Bulking up.
Like
you're
getting
right.
big muscles,
Yeah.
even like athletes.
And weight loss.
Yes, they can. See,
Bulking up.
okay.
Well,
So don't overthink that. It's just practical questions that hopefully, you know, when people ask you, you already know the answer instead of trying to. Think of answers. So this is our classroom. This is where we're going to meet because Wendy has a class there. So the next, do you have any more questions on endocrine system? Here's our, oh, here it is. So, okay. Now the cardiovascular system, which is made up of three main parts: your heart, your blood vessel, and blood. Today we're going to study the blood part, okay? And the blood is what type of tissue? Epithelium, connective muscle, or nervous tissue? Yes, it is a fluid type of connective tissue, okay? So your first lecture test will be on endocrine system and blood. Okay, so it is a fluid connective tissue, and if you think about it, it's everything, right, ends up in your blood. Everything we inhale ends up in our blood, our hormones are in the blood, and when we think blood, we always think it's the one that transport the gases, but that's where everything else is contained, right? That's like our fuel system that contains even gunk that we need to get rid of. It contains the nutrients that we just vitamins. You took vitamins, it's there. Medicine, it's there in the blood, including the gases, the important gases, the oxygen and carbon dioxide. Okay? A few things we want to remember about blood. Look, it is thicker than water and moves more slowly than water. And this is one of the dangers of steroid supplements. One of the, if you look at, we're going to study steroids in more detail when we take up the reproductive system. But testosterone, there is a pure form of testosterone that athletes use to bulk up. I think even females use that for bulking up. One of the side effects of that, or one of the effects of testosterone, more so than estrogen. Estrogen does that too, but more testosterone. It increases the red blood cell count. And that's one of the other reasons that people do steroid and steroid alternatives, because they want, it provides them, they think it gives them more endurance. They're able to do whatever activity they're doing longer. But they forget that steroids increase the red blood cell count, and look at it, makes your blood thicker. And this is why I know you've heard of some stories where some athletes, they're running and then they dropped dead in the field. This is, I'm sure they were taking steroids. That's very dangerous, okay? You think you start with a thicker blood already, okay? So what is the component of blood? If we have our blood drawn and you just let it sit there, it's really made up of two main parts. The fluid part is called plasma, and then all the cells are here called formed elements. Huh?
Five.
Number 5. Okay, so when you say formed elements, I don't know why books always say formed elements. Well, I guess it's standard, but really this means nothing but the cells. So remember, a tissue is a collection of cells. So connective tissue contains cells, fibers, the matrix, right? So there's your cells right here, which are your red blood cells, white blood cells, and your platelets. Those are the cells. That's what it means by formed elements. And then the matrix of this connective tissue is called the plasma. You won't see fibers here because the proteins are really dissolved, that they don't form fiber strands. And for the plasma, oh, by the way, know the difference between plasma and serum. Serum is clotted blood. So plasma still contains all the clotting proteins. It didn't clot yet. Once it clots, it's clearer, you call that serum. Okay? So let's look at this plasma first. The plasma, look at the most abundant component of plasma. Yes. In your next worksheet about blood, there's something about, a question about why substances, something about the necessity for water, or substances need to be soluble in water so that they can pass in the blood. And then parenthesis, think chemistry. You should think chemistry. So why is it necessary for substances to be soluble in blood? What is the function of water? Isn't it? Remember when we talked about in chapter 1 the function of water? To flush, also for chemical reactions. Remember that? Hydrolysis, dehydration. So, okay, just sit down there. Okay? So everything needs water. So chemical reactions, just think chemistry to answer that question. That's your next worksheet, okay? So that's why we have to worry about the saturated, unsaturated fat. Now it makes sense. It's because the most abundant component in blood is water. And we know that fat doesn't dissolve, it doesn't mix well with water. So we want to make sure we have the good type of fat, right? The unsaturated. Because look at 91% water. And that's why we need to drink our water, right? If water is the main component of blood, I'm thinking if I'm dehydrated, I'll have problems with my blood pressure. And if I have problems with my blood pressure, I'm thinking I won't, because this, remember the function of blood, transport of substances. I won't be able to transport substances if I'm dehydrated. So we need to be adequately hydrated.
Can the steroids also cause dehydration?
Can the steroids also cause dehydration? That's a very good question. What do you think?
Yes.
Why?
Because it makes the blood thicker.
It's the
And the streams can flow.
It makes the blood thicker. Very good. But it doesn't really cause, if you think just taking steroids itself will dehydrate you, that's not that's not the main reason. That's not really because it makes the blood thicker. If you take the steroid alternatives, the end effect is increases your urine output. Increased protein always increases urine output because too much protein is harmful to the body. So the body responds by increasing urine output. And so increased urine output, thicker blood, dehydration. Just not a good thing, right? Okay, so in addition to water, there are 3 important proteins which I want you to remember. I remember in my past test, I don't know about this coming up test, I had like a fill in the blanks. Blood is a fluid connective tissue. The most abundant component of which in the plasma is, you're going to write water is the most abundant component. In addition, there are 3 major proteins. So you need to remember what the 3 major proteins are. Albumin, globulin, and fibrinogen. So these are the 3 major proteins. Next to albumin, write blood pressure. This one, this is the key. It creates an osmotic effect. So it sucks the water and it keeps it inside your cardiovascular to maintain blood pressure. Next, globulin. Next to globulin, you're going to write immunity. Have you heard of antibodies? Antibodies are globulins. So you see people with low protein or protein deficiency, aren't they more prone to infection? Right? Because globulins become immunoglobulins, which are antibodies. So you can't make antibodies if you don't have protein.
So if you're not making albumin, does that mean your blood pressure is going
Yes?
up?
No,
Down.
not up.
Down.
Down. Very good. By the way, you may ask what part of the body makes all these different kinds of proteins. It's your liver. That's why the liver is very important. So when we eat, right, we have our diet, and then we break down our protein to amino acids. Those amino acids, when they get to the liver uses those ingredients to make all these proteins, and then it releases it. You have it in your blood. See? We're going to study that more when we take up digestion and nutrition. Does it make sense? I eat my chicken, I eat my hamburger, then I have amino acids. Then amino acids enter my body, they go to the liver. The liver will use these ingredients, the amino acids, to make albumin. Then it releases it into the blood. Globulin, release. Fibrinogen, release. It's the key is the liver. That's why we have to love our liver and take care of it. Fibrinogen. Next to fibrinogen, write blood clotting. So you heard of fibrin clot? That's the one. Okay? So know those 3 important proteins. In addition, you have this, everything. So if I ask you, don't forget, there's 2 parts to the blood, right? Plasma and the cells. If I say, where will you find your electrolytes in the plasma? Where will you find the antibiotics that you just took? It's over here. Never here. These are just the cells. Okay? So next, we look at the cells, the red blood cells, the white blood cells, and the platelets. Okay? Okay, so now we're going to look at the blood. The I'm sorry, not the blood, but the formed elements. The first is your red blood cells. But before we start with that one, I want you, I remember, I don't know again about this coming up test, but I remember in my past test, I had something like this. It's just to help you, to remind you. And students always ask, what is the purpose of that picture in the test? It's just to help you, and hopefully you remember, okay?
What number?
Slide 12.
12, okay. So look at this picture. Do you remember what part of the body makes these cells, blood cells? Do you remember? Where do you make your blood cells? If you're diagnosed with anemia or some kind of blood cancer, what do they do?
Bone marrow.
That's very good. The bone, remember the bone marrow, right? They do bone marrow aspiration. You remember that? Okay. So in my bone marrow, look at this picture. I have stem cells. There's different types of stem cells: multipotent, pluripotent, totipotent. Don't worry about that. Totipotent is the stem cell with the zygote. It's a totipotent cell because it can become anything. As you become more and more specialized, the pluripotent is just specialized to become just different types of red blood cells. Don't worry about those terms. Okay, I think the book discusses that too much for you. But look at, you have one stem cell in your bone marrow. In other words, my bone marrow has only stem cells, which can become any of these. Okay? So when do you think I need to make more red blood cells? When do I need to make more red blood cells?
When you're anemic.
When I'm anemic. Very good. When I'm bleeding. Okay? So when do I need to make platelets? Platelets are for what?
Cuts.
Clotting. So when you have a cut, very good. I need to make platelets. When do I need to make white blood cells?
When you have an infection.
When I have an infection. So in other words, it depends on your condition. This will become this, or any of these. My question, what do you think will tell this? Remember, communication. Do you think nerves will tell that to become this or this or this? Or hormones? Yes, very good. Okay? You see how important your endocrine system is. We just take it for granted. Every month we menstruate, we just take it for granted. It's hormones. So, I want you to remember the hormones. For red blood cell, it's erythropoietin. This one for sure is going to come out in your test, the hormones. Erythropoietin. So erythropoietin is a hormone made by my kidneys. Okay? So I lost blood, or anytime I'm anemic, my red blood cell count is down, so the kidney will receive a low red blood cell blood. It responds by secreting erythropoietin. This goes to the bone marrow. It will tell this to become this. Follow?
Wait,
How
say
about,
that again.
huh?
The kidneys receive a message that your red blood cells are low,
Yes.
so it tells the,
No, it secretes erythropoietin,
secretes
right?
the-
This, what is this one? This is a hormone. Very good. Then what's the target of this one? Bone marrow, right? How does the bone marrow respond? The stem cells of the bone marrow becomes red blood cells. It corrects the situation. How about, I have a cut. The hormone is called thrombopoietin. You know, platelets are also called thrombocytes. So the hormone is called thrombopoietin. You may wonder, what part of the body secretes this? The cells that were cut. Isn't it nice? It's amazing how our body has they're like little talking cells. They talk. They secrete this. It goes to the bone marrow. You have this to control the clot. I mean, the bleeding.
Is it made by the kidneys or what is it made by?
No,
By the cells that were
the
cut.
cells, the injured cells. The cells that were cut. So our body, you remember our body cells, they communicate. If it's not a neuron, they must communicate by secreting hormone factors. Unbelievable. How about if you have you have an infection? So, the infected cells secrete what we call colony stimulating factors. There's many other terms for this one, but I think to me this is easy. Colony stimulating factors, or CSF. Because look at, there's many different types of white blood cells. So my infected part of the body, they secrete these colony stimulating factors, right? And these factors go here to tell this one to make whatever specific colony you need. This, each and every white blood cell is specialized to fight a specific infection. It's amazing how your body talks. That's how they talk. So in other words, the hormones are like the words that they speak. Then the words go to wherever. When the target organ hears it, then they do what they're as they hear. Okay? You got that? So again, don't be surprised if it comes out in the test. Because I remember in the past I asked for the hormone. And I would ask, so I would have a picture like this to remind you the picture, and people always ask me, is there anything you want us to answer the picture? No, it's just, I was hoping that you remember. So the hormone, I would ask the hormone, and I think I also would ask to give me one specific condition or instance when this is going to be released. And people are just, they start getting angry. This is so difficult. I'm just asking, give me. So you write anemia. You write there's a cut. You write there's an infection. That's all. Don't, just be simple. Be simple. That's all we want. Do you think you got this, everybody? Okay? So now that we know how they are formed just from the bone marrow. The bone marrow hears, it's told, and then what is it that it hears? The hormones that's being released depending on the condition. So our first cell or formed element is this baby right here, the red blood cell. By the way, you should be able to identify, right? When you're given a blood smear like this, you should be able to identify which one is a red blood cell, which one is a white blood cell, and which white blood cell, we're going to study that one, and which one is a platelet. For now, yes, for now, I want you to know this one. I know every cell that has a pale center
It's a red blood cell.
is a red blood cell. And for now, I want you to know anything that looks like a speck of dirt is actually a platelet. Platelet. Broken little plates. The speck of dirt.
And donuts.
And if I ask you, yes, if I ask you, what is the clear space? It is plasma. What's the most abundant component here? Water. What would be present here? Here I'll find the glucose that I just ate. Here I'll find my vitamins, everything, my steroids, everything, okay? My oxygen, carbon dioxide, and then they're going to go to wherever they need to go. But when they enter the blood, they go here first. Now let's look at a red blood cell. a few things unique about the red blood cell. Write down a nucleate. It has no nucleus.
What slide? Sorry.
14.
14, thank you.
It has no nucleus. It's anucleated. Okay? And it has no, look at, no centrioles, no organelles, no nothing. It's naked, and it makes sense. What it has is what you call hemoglobin. That's all it contains. This protein here. So it's,
Does it mean it has no DNA?
yes, it is. It has no nucleus, so it has no DNA. That's why it dies, right?
That's why
It
you
dies very quickly after 120 days. Very good.
use the blood to identify
That's
somebody.
very good. Okay? It, remember, it doesn't divide anymore once it's formed. Red blood cells, muscle cells, and your neurons. But this one, very unique, no nucleus. It has nothing else but this protein called hemoglobin. Are you familiar with hemoglobin? What does it do?
Carries oxygen.
That's very good. Okay?
works?
It carries oxygen. It can actually carry both oxygen and carbon dioxide. But isn't that the job of red blood cells, to transport our gases? So, God made our red blood cells so that it will not be tempted to use the oxygen for its own benefit. It took away the mitochondria. Remember, the mitochondria is the organ that uses oxygen. It reminds me of Winnie the Pooh. Remember that story where he was supposed to bring honey to his friends, but on his way, he kept on eating the honey. When he got to his friend, no more honey. That's what's going to happen with the red blood cells if it had mitochondria. So, what it does, it binds the oxygen and it delivers it to the customers. It's not tempted to use it. Okay? It's anucleate. It has no organelles. They say each and every red blood cell has about 250 million hemoglobin molecules. And each hemoglobin, look at this picture. There's a central area called the heme pigment. This is the pigment part. And this is the globin molecule, the protein part. And I want you to look at this part right here. Iron. Okay? So the oxygen, the oxygen that we transport is transported bound to the iron of your hemoglobin. This is why if we are deficient in iron, we become anemic. You see? Because oxygen binds to the iron part of your hemoglobin. Okay? So you understand why it's anucleated, why it has no other, it's supposed to pack itself with hemoglobin. Another key feature of red blood cells, it's biconcave. So this one is, the book is very, it made sure to let you know that it's really, see, look at, it's just microns. It's really, if you look at it, it's really, really flat like this. It's just a very, very small amount of space. And this is very important, the biconcave shape of red blood cells. This is so that traveling of oxygen into and out of the cell is not that far. Does it make sense? It will quickly be released to go to wherever it needs to go, the oxygen, and then very easy to enter also for carbon dioxide. Okay? Actually, the hemoglobin can transport both the oxygen and carbon dioxide at the same time, because oxygen binds to the iron part, whereas the carbon dioxide binds to the amino part of your heme. So they have different binding sites. So if your hemoglobin has oxygen, you call it oxyhemoglobin. Once the hemoglobin has unloaded the oxygen, you refer to it as deoxyhemoglobin. The carbon dioxide binding is called carbaminohemoglobin. I want you to know that this is different from carboxyhemoglobin. Have you heard of carbon monoxide poisoning?
Yeah.
This is the one, carboxyhemoglobin. You see? Carboxy and oxyhemoglobin. This is it's a very dangerous poison because it actually binds to the same binding site, the ion. And this is carbon monoxide, just one oxygen. It binds to the ion, the same binding site for oxygen. And it actually has a stronger affinity for iron, 20 times stronger than oxygen. So if you inhale carbon monoxide, it very strongly bumps off the oxygen. And you'll die because oxygen is key to life. So the red blood cell is not able to transport the oxygen. Does it make sense, everybody? You understand this? Okay?
So if the hemoglobin doesn't unload the carbon, whatever, then you develop carbon monoxide? Does it have to unload it, or?
This one? No, it doesn't have to unload it. Look at, when you have this one, you don't have oxygen.
Okay.
So the danger of the threat of carbon monoxide is you are deprived of oxygen. Right? If that's the one that's riding in your red blood cell and not oxygen, how is oxygen going to reach your body? That is the threat. Okay? You understand these terms? So each, yes?
What is the carbaminohemoglobin?
That's carbon dioxide. That's normal. Carbaminohemoglobin is normal. Carboxyhemoglobin is abnormal. This is dangerous. Look at, I told you that, look at this one, right? Each hemoglobin binds 4. So when you say, actually, when you have oxygen delivered to your body, when you say deoxyhemoglobin, it's just delivering 1. So you still have 75% saturation. You still have a lot of oxygen to spare. Okay? That's not the case with your heart. Don't forget, while I remember, I was going to wait until we get to the heart. But remember this one, okay? As far as coronary circulation is concerned, when we say coronary circulation, we refer to the blood supply to the heart. The heart, even though it pumps blood to the rest of the body, it needs blood, right? It needs a supply of nutrients also so that it can pump. So the supply to the heart is called coronary circulation. It's getting a supply of oxygen. Each time the blood is being delivered to the heart, it actually unloads 3 oxygen molecules.
It what?
It unloads 3 oxygen molecules. That is different for the rest of the body. The rest of the body just needs 1. The heart, each round, needs 3. So now, does it make sense? Is it clear to you why, like in the ER or patients when they hook a pulse ox and the O2 saturation falls below 90, they do EKG. And then they hook a nasal cannula. They worry about the heart, you see? Each time, look at, amazing, the tremendous demand for oxygen by the heart. Coronary circulation, as opposed to circulation in the rest of the body. What is it? 3 oxygen molecules each time. Whereas the rest of the body, how many oxygen is delivered? Just 1. So you still have 3 to spare, but not the case for the heart, okay? So now you remember, because I will forget for the heart. Okay, so I just want to talk a little bit about iron deficiency anemia. Iron deficiency anemia. When you're diagnosed with iron deficiency anemia, this is something that you should take seriously. It's not, you shouldn't say, oh, okay, thank you. It should be addressed immediately. You should correct that, because okay, I think so you can understand this one. I want to look at the what do you call this? The life cycle of red blood cells. Look at this one, okay? We're gonna look at this one first. Because the red blood cells have no centrioles, they can't divide, they die, and plus they have a hard life. What you need to know, the diameter of red blood cells is about 7 microns, or even sometimes larger. And there are 3 types of blood vessels: your arteries, your veins, and capillaries. The arteries and veins, we can see it, right? But the capillaries are microscopic. And the width of the capillaries are sometimes smaller than the smallest red blood cell. If you look at this picture over here, you see how the red blood cells have to bend so they can squeeze themselves and pass through these small capillaries. So the constant wear and tear, plus they can't divide, they die after about 120 days. So our body recycles it. So look at, in the liver, you have your macrophages. Remember your macrophages, the phagocytic cells. So they just recycle your red blood cells. And what is the composition of your red blood cells? It has nothing but hemoglobin, right? And the hemoglobin is made up of amino acids, and then you have your iron. The iron is going to be released, okay? One thing you need to know, iron is toxic if it's circulating on its own freely. It has to be bound to a protein all the time. Free iron, toxic. Bound iron, no problem. Okay? So, look, the dead red blood cells, you recycle the amino acids, you can reuse that, right? Make proteins again. See? Use it for red blood cell formation. How about the iron part? The iron part is going to be recycled and reused, but to be transported, it has to be bound to a protein called transferrin. Ferrous sulfate, iron, right? Transport, transfer. So you transfer the iron from where it died back to the bone marrow. Or you can store it bound to the protein ferritin. Ferritin. Don't worry too much about these 2 proteins. I just wanted to show you so you understand the next slide that I'm going to show you. So we can understand why iron deficiency anemia is dangerous. Okay? So again, your red blood cells, when it dies, you recycle it, right? Macrophages break it down to release the amino acids. The protein is made up of amino acids, and the amino acids is going to be used again to make your red blood cells. And look at your iron wants to go back. You can recycle it, right? It has to be bound to a protein called transferrin, or you can store it in the liver in the meantime, bound to ferritin. So, where do you find iron in the body? I find it in my red blood cell. I find it bound to transferrin or bound to ferritin. Those are the three sources of iron in the body. Now we're going to look at this iron deficiency anemia. And what is the function of iron? It has to be the one to bind the oxygen so we can energize our cells, right? Look at this one. So there is your, this is normal. And this is what we want. We want to be able to oxygenate our cells, right? Look at, if you are iron depleted, no problem. You still have your stores. This is your red blood cell. This is the iron in my red blood cell. You still have iron there. You can still transport oxygen. That's the key. The oxygen in the red blood cell. You need the iron there to transport oxygen. But I want you to look at this one. People with the diagnosis of iron deficiency anemia. Look at, isn't this dangerous? No more iron in your stored part, in the transferrin, in the ferritin, including no more deficient iron inside the red blood cell. This explains why people with iron deficiency anemia, they're weak. They don't have energy. Do you think they can think properly? Do you think they will do well in the test? No, they won't. Is this dangerous? Yes. Don't take that for granted. Do you understand? So, do you think if you don't address iron deficiency anemia, can you die? I think you can, right? Because oxygen is the key to life. And this is not able to transport normal oxygen. Okay? So please don't forget that, because I think I had a question to that effect. Okay?
So there's no iron in the red blood cells or the liver? You said if you're iron deficient, there's no iron in the red blood cells or...
Where else? If you say iron deficiency anemia, even the iron in the red blood cells is now deficient. And then there's no iron here already. There's no iron there. You know where it's transported, there's no more. Yes. What is it? Okay, so do you have any questions so far on our red blood cells? So, yes?
Just a question for the iron. You said it was in the transferritin, and where else?
Transferrin, ferritin, and then in your hemoglobin. Those are the three areas where you have iron. Transferrin, ferritin, and hemoglobin. Can you also have iron toxicity? Yes, it's very toxic. So that's why don't. By the way, this one here. So we're gonna finish this one. So when we recycle this one, the heme is the coin. The coin. This is the heme part right here. This is the pigment part. So when we recycle that one, the heme, the iron is released, but the heme part is converted to biliverdin, which becomes bilirubin, and this is what gives us the yellow color in our pee-pee, urobilin, and the color in your poo-poo, stercobilin. And this explains why people with liver, because this is the liver, right? People with liver failure, does it make sense? If you have liver failure, think, I have liver failure. At the same time, my red blood cells are dying. But then my liver is not able to process the pigments. So I become yellow, jaundice, because the liver is not able to process it. What else explains or is a good sign of liver failure? My pee is clear color. There's no yellowish color to the pee, and my poop, clay color. I don't see that nice brown color in the poop. So I know you have liver failure. Jaundice, I look at the urine, I look at the poop, liver problem. You understand?
I thought
And the
liver-
frost
I
on the
thought
skin too.
Yes, very good.
I thought your PP is clear if you're hydrated and yellow
Well,
if you're dehydrated.
yes.
So how does that work?
No, even if the 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 clarity, even if you say your PP is clear, there is still a tinge of yellowness. It's not clear.
Okay.
Okay? That's very good. Very good. Confucius. But we theme it with, you look at the PP and the poop. You look at them both. So if this one doesn't have the nice brown color, I know you have a liver problem. Okay? To recycle your red blood cells, by the way, we need vitamins. Vitamin B12. You see this one? You need B12, you need folic acid. They are the ones that are key for your iron absorption.
Doesn't vitamin B6 or B12 also take the color out of the urine?
No, it adds it.
Yes. very
It
good.
makes it like neon.
Okay. So, I want you to know a few terms. Anemia, of course you know anemia if your red blood cell count is low. Okay. Polycythemia if there's too much red blood cells. So, what maintains red blood cell homeostasis? Your kidneys. Don't forget this. Don't forget. If you what do we need oxygen? I answered the question. The red blood cell. What do we need red blood cells for? Oxygen. So if you have problems with oxygen, what will solve the problem? Red blood cells. People will make that mistake. If they have problems with oxygen, they think it's the respiratory rate that will solve the problem. It's not. Okay? If we have problem with red blood cells, it's the if we have problems with oxygen, it's the red blood cells that has to respond, not your respiratory rate. Respiratory rate or your respiratory system is the key for controlling carbon dioxide level. But the blood is the key for controlling oxygen. Okay? And what is oxygen or red blood cell production dependent on? A healthy kidneys. It's the kidney because this is the one that secretes erythropoietin, which is the message that the bone marrow receives. Do you follow, everybody? What you think? Okay? The next topic is about blood typing. I think I'm going to do this last. We're going to look at white blood cells first. Break 5 minutes, then we do white blood cells.